Hello, in this video we're going to be writing equations related to exponential decay. And so I have a problem here that says we are looking at an element of, or an isotope of magnesium 27, which has a decay rate of 7.34% per minute. Now a chemist has 500 grams of that isotope. Write multiple equations to represent this situation. So what we can do, we know that the exponential decay formula, we can look at it as the amount starts with the, and then P would be our original amount, and then we have 1, we subtract our rate to the T. Now in this case, T is going to be time, and since we're decaying per minute, it'll be time in minutes. And we can fill this information in, so the amount we'd be left with, we started with 500. 1 minus, we turn our rate into a decimal, 0.0734 to the T. Or rather, A equals 500 times 1 minus 0.0734 is 0.9266 to the T. So there's one equation for writing the exponential decay of this. We also learned a few weeks ago about our PERT formula. Now we've usually used PERT for compounding interest, but it also works for continuous decay. The problem there, or the difference, is that because we're declining or decaying, our rate is going to have to be negative. So let me write that a little bit better. P e to the negative r times t. So to fill that in, we'd have 500 times e to the negative 0.0734 times t. Okay, and that is another equation that we have here. So these two equations are great for highlighting the rate at which this isotope is decaying. However, it doesn't tell us anything about how long its half-life is. And so in order to figure out what its half-life is, we need something along the lines of A equals 500 multiplied by a half to some power that we don't know times our time. Now I can set this equal to that blue formula we found up there, since I know that that is a true formula, and we can use that to solve for K. And so to do this, we would divide both sides by 500 and they would cancel. And so we have 1/2 to the KT equals 0.9266 to the T. If I take the natural log of both sides, that means I'm going to bring my exponents out, so KT times the natural log of 1/2 equals T times the natural log of 0.9266. When I divide out the T's, they're gone. And so K ends up equaling the natural log of 0.9266 divided by the natural log of 1/2. Putting that in the calculator and evaluating gets us approximately 0.110 when I round to 3 decimal places. And this number is pretty close to 1 divided by 9.1. So if I write this equation here, we would have A equals 500 times 1/2 to the, and I'm going to take T times the 1 over 9.1, which would be T over 9.1. So a value of T equaling 9.1 would mean I'd have 1/2 to the first power, so I'd be cutting my 500 in half. And so that tells me that our half-life is approximately 9.1 minutes. Okay, so that gives us information about half-life, and so there are 3 different equations right there to represent this information we got, just knowing how much we started with and our rate of decay. Okay, we are done.